Today I'm going to teach you about Charles' gas law. So what is the theory? The volume gas occupies is directly proportional to its absolute temperature if pressure remains constant. So when temperature increases, the volume increases, and vice versa. The average kinetic energy increases with temperature. So particles move faster when they are heated, which causes the volume to also increase. Gas occupies more space as temperature increases when pressure remains constant. Applications in daily life. Pop-up meat thermometers, hot air balloons, and bakeries are just some of the ways that Charles' gas law can be seen in everyday life. So pop-up meat thermometers work by temperature rising as the meat cooks and the air in the thermometer expands so the plunger pops up, like shown in the picture. And they are calibrated so that the cap pops off when the thermometer reaches the correct temperature. Hot air balloons. So the air in the balloon is heated, causing volume to increase, which results in the gas occupying more space, meaning that density decreases. In bakeries, they use yeast to make things rise, and yeast releases carbon dioxide bubbles, which when heated cause their breads and cakes and other baked goods to be fluffy. So I ran an experiment where you take a balloon and put it either in the freezer or take it outside on a cold day, and the volume will decrease, as shown in the middle picture. Once you take it back into a warm room, it should regain its shape, as shown in the last picture. The temperature will decrease, which means the volume also decreases. The increase in temperature when you bring it back inside causes the volume to also increase, and therefore the balloon regains its shape. So the formula, V1 over V2 equals V2 over V2 over T1, where V equals volume, T equals temperature, 1 represents an initial value, and 2 represents a final value. V2 equals V1 over T1 times T2, or T2 equals T1 over V1 times V2. And in Charles' gas law, it is very important to use Kelvins, not Celsius or Fahrenheit, because Kelvin goes to an absolute zero, so it starts at 0, whereas Celsius does not. And to convert from Celsius to Kelvins, you just need to add 273.15 to the given temperature. Example 1. A gas occupies 276 centimeters cubed at a temperature of 10 degrees Celsius and pressure of 820 mmHg. Find its volume at 200 degrees Celsius. So don't worry about the pressure. It doesn't ever enter the calculation because pressure remains constant. Use the equation V1 over T2 equals V2 over T1. Convert 10 degrees Celsius and 200 degrees Celsius to kelvins using Celsius plus 273.15. 10 degrees Celsius plus 273.15 is 283.15 kelvins. 200 degrees Celsius plus 273.15 equals 473.15 kelvins. V1 equals 276 centimeters cubed. T1 equals 283.15 kelvins. T2 equals 473.15 kelvins, and V2 is what we're solving for. 276 centimeters cubed divided by 283.15 kelvins equals V2 over 473.15 kelvins. So V2, once the equation is rearranged, equals 276 centimeters cubed times 473.15 kelvins divided by 283.15 kelvins. And the answer should be 461.2 centimeters cubed. Example 2. At 25 degrees Celsius, a gas has a volume of 4 liters. What will the volume be at 140 degrees Celsius? Solution. So convert every temperature to kelvins because you're given Celsius. 25 plus 273.15 equals 298.15 kelvins, and 140 plus 273.15 equals 413.15 kelvins. V1 equals 4 liters. V2 is what we're solving for again. T1 equals 298.15 kelvins, and T2 equals 413.15 kelvins. There's two different ways that this can be set up. It can either be V1 divided by T1 equals X times 400 times T2, or V1 times T2 equals X divided by T1. Either way, you get the same answer of 5.53 liters. And the last example, at 215 degrees Celsius, a gas has a volume of 300 milliliters. What is the volume of this gas at 130 degrees Celsius? Start by, again, changing everything to kelvins because you're still given Celsius. So 215 plus 273.15 equals 488.15 kelvins, and 130 plus 273.15 equals 403.15 kelvins. Again, we're solving for V2, which is V1 over T2 times T2. Or no, sorry. V2 equals V1 over T1 times T2. So V1 is 300 milliliters. T1 is 488.15 kelvins. And T2 is 403.15 kelvins. And if you put it into the equation, it gives you 247.76, that should say milliliters. Thank you for listening to my presentation.